What's that? What do you got there? All right, we are ready to go. So I am Mike Saunders, and today I want to talk to you about assumed breach pen testing, why I think it's a better model for pen testing. There's a link here that's really hard to see because I failed to contemplate that. It's redsiege.com/ABM. I'll show it at the end of the talk, and you can see it there. But that's where you'll be able to get a copy of the slide deck that I'm showing today. So redsiege.com/ABM, and you can get the slides. So just a little bit about me. I am, that is terrible. I am a principal security consultant with Red Siege. I've been in IT a while. I've been in security for a while. And I like to fish and play guitar. And as you can tell by my voice, I like to smoke a lot of cigars. This is worse. Oh, no, I don't. That is terrible. It's like worse ice. All right. Pen testing is broken. If you know me, you know I'm prone to a little bit of hyperbole, so I'm not saying all of penetration testing is broken. What I'm saying is that what we do with internal pen tests isn't working. They don't represent how real attackers operate. So what do we do in an internal pen test? We drop a box on the network, and so we're sitting with some machine that an attacker probably doesn't have on the network because it's got Kali or whatever and all our tools on it. And we run a bunch of noisy scans. We're nmapping and nessising and doing all the things. We're lobbing exploits everywhere, trying to catch shells. And that is valuable. Don't get me wrong in saying that there's not value in doing this. There is value. We need to find those issues. We need to get those issues fixed. But real attackers aren't doing this. And so consequently, our customers aren't being prepared for what they're going to see in the real world. So pen testing, this model is broken in the aspect that it's not preparing our clients for what they're likely to see out there. On the other side of internal pen tests is I want a red team. The CISO or some executive went to a shiny conference and someone told them, you need a red team. And they're like, I want a red team. And you talk to them, you're like, you don't really want a red team. But they're like, I want a red team. This is out of scope. This is out of scope. It's only external, and it has to be done in a week. And that's not how a proper red team should work. If we're going to get, pedantic here, a proper red team is like a full scope, blended threat type of assessment where if the easiest way for me to achieve the goal is to throw a rock through your window and grab whatever's sitting on the other side, that's what I'm going to do. I'm not going to be using the latest, tradecraft and burning Odays if I can use something simpler. Red teams are much different and much more complex than a pen test. And as a result, they are necessarily expensive because they take time. So they're not appropriate for a lot of client budgets. And they require a lot of maturity in our IT organizations to be able to get benefit from a test like that. Otherwise, we came in and we looked awesome, and maybe they fixed this one thing, but there's this whole host of other problems that are out there that still aren't being fixed. So that's why I think assumed breach is a better model. Assumed breach starts with the assumption that something in the organization has been breached. A user has clicked on a link and they have code executing on their machine, or they've given up their credentials. The organization is breached. What can happen at that point? That's what an assumed breach test is supposed to simulate. So I, as a penetration tester, doing an assumed breach assessment, have my client execute a Cobalt Strike beacon or run some type of code on their machine. Once I have my check-in, I start operating like an attacker might do. And we do that in two models. We have our malicious user model. That's someone who's an employee or a contractor that wants to steal or cause harm. And we have the compromised user model. And that's the model where we have a user who has clicked on a link, they've got something running in their browser, they've given up their credentials. In both of these tests, we start with a standard workstation, a representative workstation image with representative users. What I mean by that is if everyone in the company is running a Lenovo X1 laptop, if you give me a VMware image to test from, I don't have the same hardware configuration. And if you've been reading up on the Lenovos, the ThinkVantage software has a nice local privilege escalation vulnerability in it. In the assumed breach test, I would write that file to that directory, and 10 minutes after they reboot, I would have privileged access on the workstation. But from the VMware image, I might not have that. So I can't simulate what would happen to their users because I don't have the same configuration. By the same effect, if I'm trying to simulate what happens if Bob in accounting clicks on a link, I should have the same group access that Bob has so that I can access the same machines, I have the same software, and I have the same rights and privileges. If I don't have that, how can I possibly show what happens when Bob gets breached? So a terminated user is a recently terminated user is ideal because those are users that were actually out there in the wild. If we can't do that, we'll say copy a production user and make that the user that we're going to use. And this is just a little soapbox here. DA is a tool, not a destination. It's just something we use to get to the goal. I'll explain more later. So the compromised user model, we simulate a user who's clicked on a payload, and that payload is either an HTA or something that gives me code execution, or sometimes we do it where a user has given me credentials. Most of the time we do it with who's clicked on a payload and has code execution. We're executing some custom payload, and once we have that code execution running, we're operating over our C2 framework for the majority of the assessment. However, like a real attacker would, if I get credentials after I have code execution and it benefits me to pivot to remote access, if I can VPN in and do something directly connected to their network, I will do that because that is something that an attacker would do. And I'm going to have CREDS, I'm going to pivot through the network. If we're doing the assumed breach type assessment where we're simulating what happens if someone gives up their credentials, I get the CREDS and I try to figure out where can I go with those CREDS. And this is a question you need to have with your clients. Should AV or EDR be disabled? That is a good question. So I think we got Nick sitting here. He gave a talk yesterday on bypassing AV and EDR. There's another talk today. I think it's actually going on right now. I'd like to be there. Honesty, I tell you that. There's some cool stuff. There's some great stuff that's happening there. So I appreciate you all being here. We can agree, I think for the most part, that you can bypass AV or EDR given enough time. The same thing with the assumed breach assessment. That's why we start inside the organization, because we assume it's going to happen at some point. So let's make that assumption. Let's make the leap. Should we be spending our time trying to bypass AV or EDR? There is value to the client in knowing that it can be bypassed and how it can be bypassed. But those are really kind of point-in-time things, and then the vendor makes a fix, and that bypass doesn't work, but another one will work. So is it worth the client's dollars to spend our time trying to get a bypass for their particular solution? That is not a decision I can make. That is an option that I can present to the customer and have that discussion with them. Now, in the malicious user model, I'm going to simulate an employee who wants to steal or cause harm. So I'm going to be an employee. So I'm going to have an employee machine. I'm going to test on-site or remotely through a VPN, or the customer might ship me a laptop. And I start with their standard workstation again, the same machine that that employee would have. And I use whatever tooling is available on that machine. So I don't have Cobalt Strike, so I can't execute PowerShell in memory at this point because a regular user is not going to set up a C2 most of the time. Espionage, they might do that, but that's not the case we're talking about here. So what can I do with whatever is available on that machine? I'm not going to bypass or not going to ask them to disable AV or EDR or whitelist my payload. I should back up. When we're talking about this, I'm not talking about disabling AV or EDR across the organization. It's only allowing my payload to run on the initial host. After that point, everything is still in scope for whatever they have for EDR. And it'll be in scope for the malicious user model. Now, I've said real world a couple of times probably. What do I mean by that? Like, what is actually happening in the real world when we talk about the APT du jour? I don't know what the latest one is, but, you know, it's the soup of the day. Come on. All right, so APT du jour, APT 29, 34, 75, whatever the numbers are, what are they doing? And I think I've read enough analysis, talked to people that are smart in this world, that live in this world, that attackers aren't burning the latest tradecraft they have on every client. They're only using it for select targets. So if they can get by, just like on a red team, I mentioned throwing a rock through a window. If putting password in works and they get in, that is a perfectly valid test. So you have assume breach isn't like one sophistication level. It's whatever sophistication level you're trying to emulate for your client, which could be from very basic to very complex. When I was researching the talk, I came up on this blog from the Mandiant Red Team. And in this case, the client said, we want you to get to these goals. We want you to start remotely, phish a user, get access into the network, and then here's a few different systems and data that we want you to get access to. And this blog lays out a likely real-world attack scenario that we've seen played out in real incident reports. They start with phishing. They get credentials from a user. They found a mobile VPN solution that didn't have two-factor because all the rest of the organization's VPN had two-factor. But because they were able to actually root a phone and then route all their traffic through that VPN, they were able to get in without having two-factor. Once they were in, they did some targeted KERBEROASTIng, got elevation of privilege, and started pivoting through the network, going towards data and accessing high-value targets. And that's the same thing that we try to do. And we're not unique in doing that at Red Sea. There's lots of other companies that do this. It's just something that we do, but we don't hear enough people talking about it. When we're doing a test, when I'm doing one, I am trying to simulate a payload being sent to a user, and I phished them or I social engineered them into clicking it. That's the premise. Once I'm on the network, I'm doing the same thing that Mandy was talking about. I'm searching out high-value targets. Usually one of the first things I'm going to do is KERBEROAST, just so I can get those tickets on the cracker as soon as possible, because those usually take a while. And the entire assessment, I'm trying to gather credentials for the purpose of getting to the data, getting to the things that matter. And again, DA is a tool, not a destination. If I can do everything I need to get the data that the client wanted me to get to, and we know that because in the scoping call and in the initial talks, we say, what keeps you up at night? What is the one thing that if an attacker got to would cripple your business? That's the thing that we want to get to. And once we know that's our target, that's what we start reaching for during the assessment. And DA is just a way to get there because our entire job is to demonstrate impact. And to all us technical people saying, yeah, I owned the domain, we demonstrated impact. However, to the people that hire us, the people that pay the bills, the people that set the budgets to fix the problems we find, they're like, okay, that's cool. What does that mean? However, if I can show on a report, here's all your patient databases with all kinds of PII or PHI, or here's an unencrypted credit card numbers, or here, if I click this one button right here, I will complete a $10 million wire transfer out of your organization. That demonstrates impact. I don't need DA to get there, but it's just a tool to get me there. So one of the things that we do is domain fronting. Now, unfortunately, if any of you use domain fronting, you know that Cloudflare and others have been starting to ruin the party. We can no longer route our traffic through someone else's domain. Before June with Cloudflare, I could take certain domains like Cisco.com, if my customer was a Cisco shop, there were some frontable domains in Cisco.com that I could route through CloudFront to my own endpoint. And so therefore, I can blend in with traffic that's likely to be seen. Unfortunately, that's not working on all the CDNs anymore. It still works on some. But if you analyze any traffic at a customer's site, you will see that you have hosts calling out to CloudFront and Azure Edge. So we can still route traffic through those CDNs back to our C2. But we want to make sure that that traffic is hidden with some level of sophistication. If we're using a default Cobalt Strike or some other C2, their traffic is pretty heavily signatured. It's going to stand out pretty quickly if you know what you're looking for. That's whatever C2 framework. So we need to try to obfuscate that. In Cobalt Strike, that's the malleable C2 profile. And blue screen of Jeff Dimmock from Spectre Ops, if you've ever read his stuff on malleable C2 and just in Cobalt Strike operations in general, he's brilliant. You can use the malleable C2 randomizer right there on his GitHub to generate one on the fly. But I would recommend if you're trying to be more sophisticated, actually creating your own C2 profile on each engagement. So how do we simulate that initial access on a test? I got to finish this. Last year I had the spicy V8 and I didn't know you had to shake it. I was like, this isn't bad. I got to the bottom third of the can. I was like, I've made a horrible mistake. So the initial access, HTAs are still effective. We find that they still work for getting access into people's organizations. Now, you can generate an HTA out of Cobalt Strike, but you're not likely to get very far with it. There are some other methods that you can use to generate an HTA that is effective. This blog article here incorporates the next three tools down below, and it still works against some AV and EDR. Essentially what you do is you generate a PowerShell command out of Cobalt Strike, which is encrypted and it looks funky, or encoded, and you decode that, you rip out a certain part of that, you do some further decoding, at which point you take that PowerShell script and feed it to Unicorn. And Unicorn makes some obfuscated scripts that makes your PS1 less likely to get caught. But then we can take it a step further and use Daniel Bohannon's invoke obfuscation to further obfuscate that PS1. And then we take Nishang and use its out HTA to create a new HTA. And so we now have a much more obfuscated HTA that gets past some of the AVs and EDRs. Defender, unfortunately, is catching it if you follow this as it's laid out today. But there are others that it still works very effectively on. Another one is Demiguise. And Demiguise, the essence of how it works is your HTA is encoded, it's encrypted, and it's delivered in JavaScript on a page. And Demiguise looks for environmental keying factors on the workstation that it's executing on. So it looks at what IP address am I on, what domain name am I on. And if those things match, then it will decrypt the payload, but it won't decrypt the payload before. So anything that's looking at that HTA on the wire, whether you mail it in or the client is reaching out through a proxy, will just see some encrypted data. It won't see that there's an actual HTA in there until it's in the browser and decrypted in memory, which might give you a better chance getting past defenses. Macros still work in a lot of places. Click once executables. NetSpy has a great article on that, on creating click once executables. And there are so many more other options. This is not meant to be a comprehensive list. This is just meant to be some of the ideas that you can use to get that initial execution. Now, as we're operating, it's unlikely that the account that we start with will be the account that gets us to all the data we need. Sometimes it might. But usually we're going to need to find ways to pivot through other accounts to get access to different parts of the network. Oh, that is terrible. And so how do we find those accounts? So Bo Bullock, DAPTAC, brilliant. So many different tools in his GitHub that I use on a regular basis. And I'm like, thank you, Bo. Thank you. So Mail Sniper. Anyone use Mail Sniper? Got a few hands. That's good. Anyone written Mail Sniper in here? No? Okay. All right. So, Mail Sniper, I can spray against OWA or O365 either internally or externally. And I can do a password spray to get usernames that I can use, for usernames and passwords that I can use within my C2 framework, whatever I'm doing to try to now spawn a beacon on another machine as another user. Internally, I can use domain password spray, and I can make it low and slow so I stick out less. One nice effect of using domain password spray is that it will check to see how close the users are to being logged out before it starts, and if they're within one failed login of getting locked out, it won't test them. So that's nice. We don't cause problems. Kerberoasting, Tim Medine created this, and it's still magic most of the time, unless I think about it really hard, and then it's definitely magic. The traditional tools in Kerberoasting still work great. So you've got PowerView, you've got Tim's tools that he released, Brian Furman, Full Metal Cache, another Black Hills employee. has this on his GitHub, this invoke auto KERBEROAST, which is especially nice because it spits out things in a format that work directly in Hashcat. If you use things like invoke KERBEROAST, you need to massage the data a little bit to make it work in Hashcat. This just spits it out just nice. The problem with all of these approaches is that it's not how KERBEROAST works in the real world. In the real world, when a user wants to access a SQL server, it says, hey, I want to access this service. There's this exchange of tickets, at which point the user can now access the service. And a while later, the user says, I want to access this other service over here. And they go through the same exchange, and they access that service. When we're doing all of this, we're saying, give us every single ticket for every spin that's in Active Directory all at once, which is not normal behavior. So it's something that defenders can look at certain event IDs like 4769. What's the, anyone know the number? 4769. Yes. So 4769 is a sign that someone has requested a ticket. If someone requests 25 of them in 5 seconds, that's a sign that you've got a pen test. So what Mandiant did when they did their test was this low and slow approach. They targeted specific users, for instance, groups that had admin in the name or groups that had SQL in the name. And there's some ways you can do this. You can use it using PowerView, and Will Schrader has talked about it on this blog here, KERBEROASTIng without Mimikatz. The essence of it is that you do get domain user-spn, so you find out all the users that have spins, and then you request them individually with get domain SPN ticket. And you can do that in a low and slow approach, ideally with some jitter, so you're not requesting once a minute. Maybe you request one, and then you request one 3 minutes later, and then 2 minutes later, and then 5 minutes later until you've got them all. And that's Sean Metcalf's site, right? AD Security, yeah. So adsecurity.org, he's got an article that he talks about it there. So you can read up on that. Again, I'll put the link for downloading the slides at the end of the talk. Another thing I like to do is mine Active Directory. And if you've ever used Bloodhound or Sharphound, you know how great it is for getting information about Active Directory and where you need to go. If you're using Cobalt Strike, Sharphound works really nice because you can use execute assembly and execute that completely in memory on the client. It never touches disk, but you need to research the stealth options because this is noisy. So if you're trying to not get caught, or trying to, not get caught, it's probably not going to work out real well for you. Make sure you have multiple beacons as different users because that one's probably burned. Another thing that I have no idea why this works, but I know it does, I've seen it in action, is mining Active Directory schema for sensitive information like credentials. If you've ever used AD Explorer, you look at a user and you see that they've got a description and a comment field and they have maybe a bunch of different schema attributes. Sometimes, especially in large organizations, things like the help desk will put information about what they're doing in one of those schema fields for a user. Especially with service accounts, they'll be like, reset the password to blah, and it's in the schema. So you can see it in AD Explorer. AD Explorer online, you're just doing it graphical, but if you use the -snapshot option, you create a downloadable file that you can then analyze offline. And if you want to find out about it, look here. Black Hills has a great article that talks about the kinds of information, but you're looking for things like the MSFU30 password field, which is Microsoft Services for Unix. The Unix user password might have it in there. Description, comment, other fields. And hunting for group policy preference files is another place to find credentials that you can use to move throughout the network. And they're usually elevated privileges. Now, GPP, the issue that caused this has been fixed. But as we know, it takes a long time for technology to change over. And once the domain has been built and these group policy preference files are out in sysvol, they're probably still going to be there for a long time. And these files helpfully contain credentials. Lots of times they're used to provision a workstation local admin account on a machine, and that they'll push that out through group policy, or maybe they'll use it to map a drive. And the CREDS are in those files, and they can be decrypted. Again, another AD security article on how to do that. You can also look for these programmatically with PowerSploits, get GPP password. And you can use PowerUps, get cached GPP password if you're looking for a GPP file that has been cached on a workstation. I'm a little bit ahead of schedule. Damn it. Last one. All right, lateral movement. How do we get moving? Well, we can look for lateral movement opportunities with something like PowerView's test admin access. Or we can test for everything with test admin access, and this tells us if we have local admin access to a workstation, all the workstations and computers in the domain. This might be noisy, so there are other methods that you can do this individually and to make it slower, but it's an option for finding it. This is not definitely not the only means of doing it. My favorite method, which is decidedly low-tech, but it works, is trawling file shares for files that have sensitive information. Like, if it works, it's not stupid, and I feel so... It's like, man, I wish I could have done something cool on this assessment, but I won because it was in a file. And that happens so many times. I find elevated credentials in files, whether it's DA, SA for a SQL Server, some other kind of account. I find them in files all over on file shares on systems. One that is especially cool that I found out just recently from Chris Trunzer is PowerShell PS readline logs. How many know what those are? Got a couple of hands. They're essentially the bash history file for PowerShell. And one of the things, if you ever use PowerShell, you know that you need to pass credential objects to other things to interact with them sometimes. You can do that in one of two ways. You can have PowerShell prompt you for your password, or you can put the password in a variable. If you put the password in a variable and PS readline logs are enabled, your password is now stored in that history file. So I don't know the exact path, but it is the console host _ history.txt. I think it's an app data roaming low roaming, whichever the order is, Microsoft Windows PowerShell. And if you find that file, you will likely find gold. We also look for things like source code, and I don't know why this happens, but the web root for web servers gets shared out frequently. And if they talk to any other systems like a database server, you've got a web.config in there that probably has connection strings. And those connection strings, those credentials probably used by several other service accounts because those get shared all the time. But it's not just about getting credentials. Because I've talked about, it's not about DA is not the destination. We find sensitive data. We're just looking for data on things like this. And looking for credit card numbers that aren't encrypted, looking for PHI in files, looking for intellectual property that should be restricted. Another thing, looking for the IT folder. Honest to God, the IT folder is where I find most of the things. It's not properly restricted. And there's some spreadsheet, there's some script, there's something like that has the passwords that I need to get somewhere. But I find all kinds of data. And you can do that manually. And once you've done it enough times and you start mapping out the shares that are on the network, you get a pretty good feel for what's in that folder just by the name. You can do it programmatically looking for all the shares with PowerView, invoke ShareFinder. And if you add the check access flag, it will tell you if you have access to that share. And you can use find interesting domain file share or share file to search for files with a wildcard, like any file that has the word password in it, for instance. Or find interesting file to search on a local system. And also look for session type files. So things like SSH private keys, RDP files that have credentials bound to them. FileZilla, WinSCP, there's all kinds of services out there that have these configuration files that have passwords in them. Sometimes they're encrypted and you got to go through some magic to get to them. But these session files can allow you to move around the network as another user. You can look for them automatically using Session Gopher. It's another great tool. Thanks to Chris Trunzer for teaching me about that one. Now, this next technique is something that works great, especially if you're doing the malicious user model where you've got to bring your own tool set. I have bring your own PowerShell, but there's no reason that this couldn't be bring your own Booleang or bring your own Iron Python. One of the things I like to do with PowerShell, I know Nick was telling us yesterday that PowerShell's dead. In a lot of places, it is dead, but there's a lot of places it's not. And I love the ISE if I have graphical access, because the ISE will allow you to execute PowerShell even if PowerShell is disabled on the system, if PowerShell scripts are disabled. Because when you paste PowerShell into the ISE, it is not a script. It's just something else that PowerShell that executes like PowerShell. But it magically becomes a script right when you save it. Once you save it and you try to run it, you'll get the message script execution is disabled. So just don't hit save, and you can execute PowerShell. So there's a way to get PowerShell execution even if you don't have it. Another brilliant way to do it, again, Brian Farmer, Full Metal Cache, Powerline. Anyone played with Powerline? A couple of people, anyone? Wow. Powerline is great. You really need to check it out. Powerline is a self-contained portable PowerShell execution environment in an executable that you can drop anywhere. You still have to deal with AV and EDR seeing it sometimes. You got to work around that. But you take Powerline, it's got a configuration file, and you say, I want my Powerline to include Mimikatz and Invoke Auto Kerberoast and Power Up and Power Up SQL and PowerView and whatever else you want. You run the build script. It goes and downloads all of those various PowerShell scripts that you want included. They get compiled into the final executable, and then that executable contains all of those. So when you run, you just run like Powerline dash something, invoke Mimikatz, and that's all compiled into this binary. And you now have your PowerShell environment in an environment where PowerShell was disabled. So there are a lot of pros and cons on both sides of this for assumed breach testing. On the pro side, we talked about the whole point here is to help our clients understand how they will perform against real-world adversaries. So doing this type of test gives them a better understanding of their strengths and weaknesses as it pertains to those kinds of adversaries. And we can make our test as sophisticated or simple as we want by just going out and reading the TTPs that are used by various threat actors and emulating those. On the downside, attackers have a lot of time. Just like when I talked about domain fronting, attackers have the privilege of, the ability to go out and just compromise someone's website and be like, I'm going to use this to distribute my malware. We can't do that. So that's why we have to use domain fronting to try to hide our traffic. Well, they also have unlimited time, and we have a limited amount of time. And so if we want to demonstrate the same impact, we need to move at a faster pace than a real attacker would be moving, which means we probably need to be noisier. There are trade-offs. So it's hard to do a one-week assumed breach test that shows real impact and also tries to hide from a really good blue team, because we need to be slower, and being faster means we're noisier. So there is one potential con there. It's also not focused on vulnerabilities. So this is a con because on an internal pen test, we find all kinds of vulnerabilities that need to be patched, configuration issues, things like that. In an assumed breach test, we may report on those because we may end up finding that there's a vulnerability that we can use to get access, something like that. And so if that's what we have to do, we'll use it. But it's not our focus. So there may be glaring holes that aren't patched on a network, and we don't know about it. We haven't reported on it. And if we don't report on it and the client hasn't patched it, they might not know about it, so it's still going to be there when we leave and issue our report. And we can be really hampered by not having those representative accounts and workstations. If I don't have an account that has the same privileges as the user I'm trying to emulate, I can't access the same resources they have. Same thing with the workstations. We've talked about, like software that's on a workstation, because there may be a local privilege escalation or an information disclosure in the software that's on a standard image that we don't have, that had we had that, we would have ended up in a completely different place on the pen test. So it's critical that we have those representative accounts and workstations. So to try to wrap things up, I think that assumed breach pen testing is a better way to prepare clients for the attacks they're likely to face. They can actually see what attackers might be doing, the techniques that they would use, and their own ability to see those techniques. What do they have? Do they have visibility on it, or do they not? But it does require maturity in the target organization. So if it's a new company that doesn't have, or it's a company that just doesn't have very mature IT processes, this might not be for them. There are still people that have never had a pen test. I did one this year. They'd never had a pen test. We could have done assumed breach test, but then we wouldn't have found that, there are all kinds of things unpatched. Null sessions are enabled, SMB v1, LM&R, NBNS, all kinds, 4-character passwords, things like that. Like, we might not have found all of those things. And I think that they might have been better served by doing the internal pen test than we would have done on assumed breach, because yes, we assume that you're going to be breached, and we assume the attacker is going to get everything because you just don't have that built up, that maturity. So you may need to work with your clients on doing vulnerability assessment and pen tests for a while to get them into shape where they're ready for an assumed breach test. Again, work with the client to get good accounts and workstations. And I know that I have said PowerShell and Cobalt Strike a lot. Just using it as a matter of reference is not absolutely the thing that you should be using. It's just something familiar. There are so many different good C2 options that are coming out that if we put some work into them, can be really great. Learned about Throwback and Slingshot earlier this week in a class that still looks good. We have things like Faction C2 and Sliver and I think Merlin, and there's a whole bunch of them. They're coming out. There's so many different options available for you for C2s. And the same thing for executing code. Marcello from Black Hills, Byte Bleeder. Follow him, learn, because blowing my mind with some of the things he's doing, like with Iron Python and Booleang, and running alternative languages in .NET on systems where PowerShell, the reason we're getting killed on it is Microsoft spent a lot of time investing visibility into that. You throw a different language like Iron Python in there, and they're like, it's something. Must be good. And they allow it to run. So unless you have a really good EDR that's doing, heuristic type things like that behavior is odd, you're going to get a lot farther with those kinds of languages. And you can, if you have the ability to develop, you could really port any language you wanted into .NET, not tell anyone about it, and you'd have a lot of ability to continue running for a long time without being seen. So there's a research project for you. So with that, I am Mike at redsiege.com. If you have questions, comments, whatever, Hardwater Hacker on Twitter. And I know this is tiny, but redsiege.com/ABM, redsiege.com/ABM is where you can download these slides. And I'll tweet it out afterwards too. So you can download a copy of the slides from there. And if you have any questions on it, I would love to hear it. I do want to thank Derbycon and the staff for having me here. It's, I think, my 6th Derbycon and my 4th time speaking, and it's been a privilege every time. And thank all of you for being here, because it's just incredible being at Derbycon and being able to do this. And I appreciate all of you. So with that, that's all I have. Are there questions? I will also add that when we're done, there are a bunch of stickers on the front table that you should take with you, so I don't have to take them home. Any questions, comments, concerns? Going once. Yes. Do I have any shirts? No. Tweet at Tim Medine for complaints. Trade for a spotted cow? If I had shirts, I could take this one off. All right. Thanks, everyone. That's all I have.